Friends, hope you're doing good. This is lecture for today. You have to done all these questions in your notebooks. The first question you have to do in this lecture is 5.11. That is, can you determine the mass of our moon? If yes, then what you need to know. So for to find out the mass of moon, you just use the formula that we have uh, used for the mass of Earth. You just change the subscript like me with r square, and gravity will be represented by gm, as the gravity on the moon is equals to gm, and g will be remain the same. So all these values, they are written over here. So in this way you can calculate the mass of moon. The next question is 5.12. Why does the value of g varies from place to place? So the answer is the value of g is inversely proportional to the square of the radius of the earth, that is g is equals to gme by r square. But it does not remain constant, it decreases with altitude. The value of g is greater at sea level than at the hills. 5.13 is explain how the value of g varies with altitude, and the answer is you have to write the value of acceleration due to gravity depends on the radius of the earth at its surface. The value of g is inversely proportional to the square of radius of earth, but it does not remain constant, it decreases with altitude. Altitude is the height of an object or place above sea level. The value of g is greater at sea level than at hills. Consider a body of mass m at altitude h, as shown in figure. The distance of the body from the center of earth becomes r plus h. Therefore, using equation, we get gh is equals to gme by r plus h whole square. According to the above equation, we come to know that the height equals to 1 earth radius above the surface of earth, g become 1/4 of its value on the earth. Similarly, at a distance of 2 earth radius, the value radius above the earth's surface, the value of g become 1/9 of its value on the earth. And you also have to draw this diagram with this question. The question 5.14 is, what are artificial satellite? First of all, you have to define what are artificial satellite. Scientists have sent many objects into space. Some of these objects revolve around the earth. These are called artificial satellites. Explanation: most of the artificial satellites orbiting around the earth are used for communication purpose. Artificial satellites carry instrument or passenger to perform experiments in space. Large number of artificial satellites have been launched in different orbits around the earth. They take different time to complete their one revolution around the earth. 5.15 is how Newton's law of gravitation helps in understanding the motion of satellites. For that, you have to write the complete topic of motion of artificial satellite. A satellite requires centripetal force that keep it to move around the earth. The gravitational force of attraction between the satellite and the earth provide necessary centripetal force. Consider a satellite of mass m revolving around the earth at an altitude h in an orbit radius r0 with the orbital velocity v0. The necessary centripetal force required is given by the equation Fc is equals to mv0 square by r0. The value this force is provided by the gravitational force of attraction between the earth and the satellite and is equal to the weight of the satellite. W is equals to mg. Thus Fc is equals to W is equals to mgh. So if we compare this equation, we will get mgh is equals to v0 square by r0. M will be cancelled out with this m, and we will get v0 square is equals to gh r0. So v0 is equals to under root gh r0 under root. R0 is equals to r plus h. V0 is equals to r gh into r plus h under root. So the above equation gives the velocity which a satellite must possess when launched in an orbit radius r0 equals to r plus h around the earth. An approximation can be made for satellites revolving close to the earth such that r is greater than h. So in this case, r plus h will be equals to r, gh is equals to g, and v0 is equals to gh under root gr. So this is the answer of this question. So question 5.6 is, on what factors the orbital speed of a satellite depends. So orbital speed is given by v0 is equals to gh r plus h under root. Formula shows the orbital speed of a satellite depends upon g, r, and h. The factors are the mass of earth, the mass of satellites and distance between the center of Earth, also the gravitational constant, which is involved in a set of equations that relates these factors to the orbital speed of the satellite. The last question is 5.17, that is why communication satellites are stationed at geostationary orbit. Communication satellites takes 24 hours to complete their one revolution around the Earth, as Earth also completes its rotation about its axis in 24 hours. Hence, these communication satellites appear to be stationary with respect to the Earth. It is due to this reason that the orbit of such satellite is called a geostationary orbit. So these are the questions for of unit 5, and you have to complete all these questions in your notebook. If you have any confusion, you can ask me in a GC comments or on a WhatsApp group, right? Okay, thank you, and Allah Hafiz.